Hi, I'm Joe. I'm going to present our paper, Decision-Focused Summarization. Human decision-making requires making sense of large amount of information. This includes reading through tens or hundreds of documents. For example, investors need to read a lot of analyst reports or business news to make their decisions. But it's not human strength to digest this amount of information. Summarization can help in this scenario by identifying the most relevant information and save people's time. Typical summarization methods do not account for a target decision. When the amount of information increases, summarizing for all aspects can be redundant. So now let's image a doctor making a diagnosis for heart disease from a general summary of medical notes. From this general summary, the doctor may only need the information related to the heart disease. And the fact the patient sprained the ankle when playing basketball is less useful for this purpose. So a general summary that summarizes all aspects of the source document might not be optimal for human decision-making for a target decision. In this paper, we propose a novel task, decision-focused summarization, where we want to generate a decision-focused summary, and the contents of a decision-focused summary are all relevant to a target decision. More importantly, when humans making decisions based on decision-focused summaries, they should perform better than those people using the general summaries. Now, let's take a look at the problem formulation of decision-focused summarization. So first, given an input X, which is comprised of many sentences from the input source, we want to select a subset of sentences, delta X, as decision-focused summary to support making the target decision Y. Inspired by investment decisions given analyst reports, we consider a future rating prediction task in the context of Yelp restaurant review as a testbed. This allows us to have access to both the datasets and participants who may be able to perform this task. Specifically, we have the first 10 reviews as our input X, and it's worth noting that the concatenation of first 10 reviews is actually pretty long. The average token length is 1,600, and the average sentence length is about 100. We want to use the first 10 review to generate the decision-focused summary delta X to support predicting the future rating, the average rating of first 50 reviews. This task is analogous to the investment scenario. We are asking people to predict a restaurant's future rating given current analysis. Now let's go to the method. We propose an extractive decision-focused summarization method for this problem, the DecSum. In DecSum, we will use a supervised model that is trained to infer the decision from the input text. And in this paper, we treat it as a regression model, but it could also be a classification model in other tasks. And then we have three loss objective components: decision faithfulness, decision representativeness, and textual non-redundancy. We'll use these three components to help us select sentences to form our decision-focused summary. Next, I will explain each in detail. So in the first decision faithfulness component, we want the generated summary leading to the same decision with using the full input based on the supervised model. And specifically, we want the f of delta x to be as similar as possible with the f of x. And the second component is decision representativeness. As we know that individual sentences in the full input x can lead to very different decisions on their own. Thus, in addition to decision faithfulness, model decisions of selected sentences should be representative of the decision distribution of sentences in the full input. To get a sentence-level decision distribution of the input X, we apply the supervised model F to each of the sentences in the input X to get a decision score set Y hat X. Then we can convert this set into a density plot on the right-hand side. So the x-axis is sentence-level predicted score, and as we can see, there are more sentences that are indicative to a higher future rating, compared to those that are indicative to lower future rating. Also, there are some sentences in the middle, and they are probably represent the sentences with neutral sentiment. We do the same thing to the generated summary to get a sentence-level decision distribution of delta x. We then measure the distance between these two distributions by Watson's distance, and this is our second component, decision representativeness. The last component is textual non-redundancy. This is similar to typical summarization methods that we want the summary to cover diverse aspects of input documents, and specifically for each sentence in the selected summary set, we want it to be dissimilar with other selected sentences. Finally, we use greedy algorithm to iteratively select sentences with hyperparameters. to control the strengths of each component. And in practice, we use Bing search to improve our performance. Now let's talk about the baseline methods in our experiment. So we have two groups of baseline methods. So first is the text-only methods. In text-only methods, we have abstractive summarization parts and an extractive summarization method PreSum, and also a random selection. In the other group, we compare with model-based explanation methods because they also use the supervised model to assign sentence importance score. In this group, we have integrated gradient, IG, and also attention. And this slide is a result of automatical evaluation on decision faithfulness. And recall that in decision faithfulness, we want the generated summary lead to a similar result compared to those using the full input. That is, we want the f of tilde x to be as similar as possible with the f of x. And in this table, the MSE with 4, we compute the mean square error between the f of tilde x and f of x. And first, let's look at the text-only summarization methods. We can see that these three methods perform similarly, and random is even better than the abstractive summarization part. Next, we go to model-based explanation methods. In these methods, the IG is performed better than attention, but both of these two methods are worse than the text-only summarization methods. Now, for the proposed DecSum, we can see that DecSum with 3 components performs significantly better than all the baseline methods. And even without the decision faithfulness components, it can still outperform the baseline methods. The MSE on the right column means that we compute the mean square error between f of tilde x and the ground truth y. And we can see that the trend is similar with MSE with 4, that DecSum with 3 components on still perform the best. Next, automatical evaluation of decision representativeness. In decision representativeness, we compute the Wasserstein distance between the decision distribution of the input x and the decision distribution of the generated summary tilde x. We can see that DecSum with 3 components on reach the lowest Wasserstein distance, and DecSum without decision representativeness components still better than other baseline methods. And on the right-hand side, we can see model-based explanation methods are much worse than other baselines, and this is because they tend to select sentences with extreme sentiment and ignore the sentences in the middle. Human evaluation is very important in our task, but humans are not good at telling the difference between rating of 4.1 or 4.2, so we simplify our task to compare future ratings of 2 restaurants. So first, we will find a pair of restaurants with the same average rating for the first 10 reviews. Then we will generate the summaries based on the same summarization methods for these 2 restaurants. And finally, we ask participants to predict which restaurant will be rated higher after 50 reviews. And note that we make sure that the difference between their average rating after 50 reviews will be equal or greater than 1 star. And in this task, we want to know which summarization method is more useful to help users to tell the difference of future rating between 2 restaurants. And turns out this task is very challenging for humans. Only DecSum allows humans to outperform random guess 50%. And the random selection baseline is the second best among the selected methods. If we are looking at the performance of individual participants, there are actually 3 participants that can achieve 90% accuracy with DecSum. And here are pairs from the same 2 restaurants in our human evaluation, and one from PreSum and one from DecSum. So PreSum sentences are those green stars on the decision distribution, and we can see that PreSum mostly select the sentences that are indicative of the higher future rating, so the Turkers cannot tell the difference between these 2 restaurants. In contrast, DecSum was able to select a sentence that's indicative to lower future rating, so the Turker can tell the difference between these 2 restaurants, so DecSum can lead to the higher accuracy in this task. Conclusion. So in this paper, we propose a novel task of decision-focused summarization, which aims to generate decision-focused summary to support human decision-making. We also propose an extractive decision-focused summarization method, DecSum, which can outperform text-only summarization methods and model-based explanation methods on both automatic evaluations and human evaluations. This paper is just a starting point. We are very excited for the future applications in finance and medicine. And thank you for your listening. Please feel free to contact us if you have any questions. Thank you.